Well, folks, good morning. Here in Salt Lake City, Utah, where I am located, it's 10 a.m. in the morning and it's been snowing, and I've had to get all the snow off my car, even though it's spring. And I am thrilled to be here today with my friend, Keith McCormick, one of my colleagues at LinkedIn Learning and all around great guy. And we're going to introduce ourselves in a minute, but if you're out there, I would love to hear from you and take a moment for you to write a comment and say hello and tell us. I should actually edit that. Tell us where you are. We would love to see who all is out there. And I also know that a lot of people are going to be watching this as a recording at a later point. This will be available on LinkedIn and on YouTube almost as soon as we're done. And you are also welcome to make comments and send us messages then. We would love to find ways to support you in your own data work. So very briefly, I'm Bart Polson, and I've made several versions of a course on SPSS for LinkedIn, recently revised it. It's the 4th edition. And we're going to talk about that and how it works into one of LinkedIn Learning's learning paths. Very quickly, Juan from Madrid, thank you for joining us. And it's probably after work for you, but it's nice to have you here. Keith, why don't you take a minute and introduce yourself?
Yeah, so it's noon where I am, so good afternoon, but also good evening to folks that are in places like Spain. I'm based in Raleigh-Durham, North Carolina, and I can't claim to have any snow. That's pretty rare here, but this is a lovely time of year when it's cold at night and warm during the day, and I just love it. So this is a beautiful time of year to be in North Carolina.
Wonderful. And Vanessa in Sweden, I'm just going to assume that you have snow. You must. And thank you for joining us. So we have half an hour here to talk together, and I need to explain a little bit about how all this works. Now, I know that most of you are joining us from LinkedIn, and so you've got the announcement there. You're logged into LinkedIn. You may or may not be familiar with LinkedIn Learning, which is obviously connected, but it's a separate service. LinkedIn Learning is a paid library of video courses, and Keith and I both have tons of stuff on there that's available. Once a week on Fridays, I share one of my courses for free. On the 1st, 3rd, and 5th Fridays, it's an English one. On the 2nd and 4th, it's a translated course. And we're able to share some of those materials, but you can also get access either through your employer or through your own account or through a school or university or even a public library, depending on where you are. So there's a lot of different ways to get hold of this information and learn to, use it in your own work.
A couple of quick suggestions related to exactly that. So first, why don't you and I put a couple of hashtags in the chat?
Yep.
I think we can do that while we're live, right? I can click on.
Yep. You can post.
But you have a hashtag I'm sure you use with your Friday free ones, and I use free first Fridays. I do it the first Friday of the month. I push out one of my courses, so we both have a similar.
Okay, so I have free course Friday.
And I have free first Fridays. It's not letting me add to the chat, but it's free
Fridays with an S at the end.
Yep.
Okay, so there are 2 ways to get courses. We got free course Friday, I do every Friday, and free first Friday with Keith. And so if you search for these on LinkedIn, you'll be able to get access to these courses. Free first Fridays and free course Friday.
I'm double checking it right now.
By the way, I do have another one for individual things. I also have something that we call Testing Tuesday. And my current one that I'm going to answer tomorrow is, in fact, an SPSS related question about recoding variables. Just a little short multiple choice thing. So you can get those and follow along. Now, let me show you what it is that we're talking about today. I'm going to bring this up, and hopefully you can see that now. This is a learning path on LinkedIn Learning. In fact, if you want to find that, I've got a ticker here at the bottom that will show you how you can get to that. If you go to https://bit.ly/SPSS-path. So it's bit.ly SPSS-path. That will get you to this page, which explains what's going on with the learning path. It consists of, let me see, I've got it somewhere. There we go. It consists of 6 courses, and it's a little lopsided here because I've got 1 and Keith has 5. But I've got the first one. I've got this course that is SPSS Statistics Essential Learning, and that's how LinkedIn Learning labels their introductory foundational courses, the essential training. And I've got that one there, and it's about 2.5 hours long. It used to be 6 hours, and I cut it way, way down, in part to point people to these other courses that Keith has created. And Keith, why don't you describe, say a little bit about your courses?
Sure. And you mentioned before we went live, you were mentioning a little bit about my coverage of the modeling topics, and that's fair. So setting up the data, metadata, all that kind of stuff, you want to start with Bart's course. So it is placed appropriately as the first course in this learning path. But I'm really proud of the linear regression course because, as you can see, it's not trivial in length. It's about 4 hours, but just on that one topic. That's it. Only covers regression. And I don't know about you, Bart, but when people ask me where people should start, I usually say decision trees, linear regression, and some articulation of a life cycle, like CRISP-DM I'm a fan of, or something like that.
You
But
know,
usually
I start, I'm even more basic than that.
yeah.
I tell people bar charts, line charts, and you need permission to do more than that. I'm a huge fan of linear regression. I like decision trees, but it turns out they require a lot of data, more than most of the people that I work with. Their data sets are not large enough to make stable, reliable decision trees.
Yeah, I'm increasingly associated with the machine learning crowd.
Yep.
Well, let me briefly go through the rest of the list, but then I want to talk a little bit about your audience because our careers are going slightly different paths. Where I'm more of the consultant. You're obviously you do some of that, but you're mostly in the academic realm. So I think we attract somewhat different audiences. But the classification modeling, I had a lot of fun with that. I also tried to keep it reasonably short. The whole idea of the classification modeling, which is done in SPSS Modeler, and I'm sure we're going to talk more about that, even though this is a fast-moving half hour, but SPSS Modeler is kind of a sibling product to SPSS. It looks rather different. It's really more for the machine learning crowd. But in classification modeling, what I do is I walk you through, it's almost exactly a dozen. I think it's either 12 or maybe a baker's dozen of 13 different algorithms, just tackling the same problem using things like binary logistic, and then a short introduction to trees.
Here it is. Here's the classification course.
Yeah, so I kind of it's kind of the parade of algorithms, I guess you could call it. But it's a great place. It's a great place to start if a lot of these algorithms are new, and you basically want something that amounts to about 10 minutes per algorithm or so.
All right. Then you've got the decision trees and then advanced decision trees.
That's right. And that's really just was 2 courses, because when I first joined LinkedIn Learning, I think it was 2016. I know that you've been doing it substantially more years than me. That particular year, they were really trying to keep the courses a little bit shorter. So we ended up doing like a part 1 or part 2. So you definitely want to take them in that order, but read the descriptions to see if the algorithm that you're more interested in. I cover Shade and Cart in the first one, and C50 is another popular algorithm. That's in the second one, purely because that year we were trying to keep the courses a little bit shorter. Then I do clustering and association in the final one in the learning path. And to give you some idea of what prompted this revisiting of the topic, because we got together to talk about SPSS last year too, but this time we really wanted to tell people about the revisions, because we've been hard at work updating every single one of these within the last several months. And for instance, HDB scan was added to the course because that was added functionality to Modeler. That algorithm has been around for quite a while, but when I first did the course, it wasn't available natively. You could have run it. You could have jumped through hoops and run it with code, but now it's available natively in SPSS Modeler. So that's the kind of thing we've added. I went through every single video in all those courses and said, is it current or not? Almost everything was current, but it was missing some things that were new. So that's what I've mostly done.
And I was scrolling through this a moment ago. If you're looking at it, you can see that this one is updated 2 months ago. This one's July of last year, but all the rest of them updated within the last month. And so it's nice to have stuff that is fresh and available for you. But I'm going to turn off this ticker and turn off that little screen sharing for a moment. By the way,
as far as how current it is, I would add one thing to that. It also gives everybody peace of mind that if they're looking at a video that they sense or they guess wasn't updated in this last round, it was checked to see that it is good to go in the current environment. So for instance, in the regression course, I think I added the XGBoost linear node. I added something that was new, but I also double checked every single video to make sure that it was current in the current interface. So that also gives you peace of mind. It's not only about the new stuff, but that the older stuff was double checked.
Yeah, I'm trying to think. I think I've been using SPSS since like version 12 or something, and some of the stuff is still the same. Anyhow, now let me follow up on something that you said, Keith. You and I are kind of approaching this from different angles. You are working more with the machine learning. And even though I have several courses where I talk about data science, machine learning, and even some, more recent models that fall into the AI rubric, my work tends to be either with my fellow academics. I am a professor. In my degree is in psychology, and I'm in a behavioral science department, soon to be psychology department. And I work with several of my colleagues and students on their academic research. And I also do consulting work through a free event I run called the Data Charrette, where we work with local nonprofits and we help them with, really every single project. This is kind of funny. I think every single project I have ever done in my life, so 30 years of statistics, has all been spreadsheet focused. That it all fit into a single page of the rows and columns of a spreadsheet, and at most a few thousand rows. And I think that's a really, really common situation for smaller organizations or people within large organizations. I've worked with the U.S. State Department, and I've worked with Visa, the global finance company, and still the data they gave me fit into a single spreadsheet. But Keith, you've dealt with different kinds of data in your own work.
Yeah, so I started out, I think we talked about this last time, the audience may not know this. I started out as a software trainer for SPSS Inc. before IBM purchased SPSS in 2009. So between the late 90s and 2009, I basically was a contract trainer. I went around and I was an employee. I was a contractor, so I was paid by the day. But there were years that it was like 150 days out of the year, which is a substantial chunk of the work days in a calendar year for sure, if you do the math. So I absolutely, the organizations I was seeing frequently at the time, it was structured rows and columns data. And, we weren't hitting a database with that. We learned how to do it. We demonstrate how to do it in class, but it wasn't needed all that often. Organizations like AARP, a lot of marketing analytics, a lot of institutional research with the universities. And that was really like the first 15 years of my career. Now, particularly, I just had a affiliation change because last week there was kind of exciting news. The small consultancy that I work for was acquired. So I'm now part of a larger organization, but I have colleagues now that are doing things like computer vision, large language models, and getting much more into that unstructured data than ever before. But I think it's fair to say that even across these 6 courses, your material and mine, there are some differences, but we're not getting into things like large language models and computer vision. That's not what you turn to SPSS
That's
for.
not SPSS stuff usually.
Yeah.
But I did want to follow up. You mentioned, especially because some of yours are done in SPS Modeler. I don't, I've never used Modeler. So maybe you can explain a little bit about when you're using that, what it's like, and how it connects to SPSS base.
Sure. So the idea behind SPSS Modeler, if I know I was still an undergrad in 1991. Well, that was the year I graduated. But in 1991, this is the story that I've heard. That Christmas was when somebody went to uh, the whiteboard and drew this basic concept of what was then called Clementine, and it became something that clients could use for the first time in 1994. So can you imagine? This year would mark 30 years since it was available and more than 30 years since it was conceived. It basically looks like a flow chart. So folks these days are used to this kind of look because Alteryx, Data Robot, countless machine learning platforms have this flow chart where you have, in fact, I even have kind of memorized the shapes and symbols. You have a circle for your database, and you then draw an arrow, and it might go through a data prep step. And then it might go through another symbol and be divided into training and test data. And the training data is exposed to the modeling algorithm. And then the test data is checked to see how accurate it is. And you're flowing through these different steps. So you don't have, when you first see SPSS statistics, I think it's fair to say that it looks like Excel. There's some really important differences, but it physically resembles Excel. SPSS Modeler does not. It looks blank when you first look at it, like same way that if you looked at some kind of drawing program and you've got these little libraries or palettes of symbols that you drag into place and then connect with arrows. But by drawing that flow chart, you have written the code. You're not drawing the flow chart to clarify in your mind what the code has to be. The drawing of the flow chart is the code. So that, in a nutshell, is what SPSS Modeler looks like.
Now, let me just ask quickly, the one that people always talked about when I was in grad school, because a lot of people wanted to do structural equation modeling, was Amos.
Hmm.
On the other hand, I'm a Mac user, and so I've never used Amos because that's I think it's still Windows only. But Amos is a totally separate product from Modeler, correct?
Oh, yeah, very different. Yeah, so structural equation modeling, really interesting stuff, actually, and I have used Amos. I mention Amos actually in the regression course for just 2 or 3 minutes, just to say that it exists there. And when structural equation modeling comes up as well, it's not a course that is part of the SPSS learning path because it doesn't use SPSS, but I also mention Amos and a course about causal inference that folks might find interesting.
In fact, I was going to mention that one earlier. So Keith, he's got this host of course here. Let me just show you again. He's got these several different courses he's done on machine learning. But I think that he's got a bunch of other courses, and I think one of the best things that Keith has done is his course on causal inference. And actually, it'd be great if you could describe that one for a minute, because I think it makes such a big difference in people's data work, because here's my argument. Data is inherently correlational. No matter what you're doing, every analysis is inescapably, inevitably correlational. But what people always want is causal inference, because that's the safest way to get an actionable insight from the data. You're trying to say, well, if you then do this, this will happen. And you can sometimes do that with correlational data, but causal inference is this whole own special thing. And that's something that you have a lot of expertise in.
Yeah. So, and thank you for that setup. I think that's a helpful way to frame it. We're basically taught in stats classes that talking about causality is verboten. It's basically, oh, don't say the word, right? But we all know that, if you're going to go into your thesis defense, and, I don't have a graduate degree myself, but I'm sure you have countless students because of your background in stats and because you're known for that. I'm sure that even master's and PhD students in other departments come to you and probably are just desperate to get advice about the stats part of their thesis, even though they might, in fact, probably aren't stats majors, right? So that's the kind of thing that I try to tackle with the causal inference. So the quick version behind that is really two things. I became intrigued with something called Bayesian networks based on the work of Judea Pearl, which is really, if you start at that step, it can be pretty intimidating because there's a lot of theory that you need to do that. But I was thinking, boy, this is something that people should know about. And I tried to make a list of the prerequisites that would get people comfortable with that topic. And then the list of prerequisites was so long, I said, I really have to do a course that kind of lays down this whole foundation. I probably would have never done it, except that in 2020, a lot of us had more time at home than we normally did. And I said, I'm going to take advantage of this time at home and I'm going to tackle this complex course and I'm going to do it. And it grew enough that it ended up being two courses. So
Here they are.
Yeah, thank you so much for putting that up there. So one compares how statisticians convince each other, that they're right when they write papers and drug studies and those kinds of things, compared to what do the machine learning folks do. It's not like the machine learning folks are uninterested in evidence. Of course they are, but they approach the world in a different way. And I compare these two worlds, and that's that one. And then in the causal inference one, you've kind of earned your way into that one if you do the first course. So they are sibling courses back to back.
And I just want to emphasize, to the people watching this, look, you may be familiar several years ago. Actually, let's go back many, many decades. I think it was Wigner wrote an article called "The Unreasonable Effectiveness of Mathematics." Really a foundational article for a lot of people working in the data world. And then back in I can't remember if it was 20 or 30 years ago, maybe 20 years ago, several people at Google wrote one about the unreasonable effectiveness of data. And what they were essentially arguing is that with enough data, correlation is sufficient. And I agree that for predictive analytics, absolutely true. If all you're trying to do is predict, great. But and if you're building a machine learning model that is going to simply operate on the predictions, that's what image classification is, predictions. And that's
I think the classic example of what you're talking about, Bart, would be product recommendation.
Yeah, a recommendation engine.
Is it really that big a deal if the algorithm says if you like this book, you'll also like that book, and I read one paragraph and say, not really my jam, right? Not that big a deal, right? So if it's prediction and it works 90% of the time, let's say, you don't need that causal explanation. But I love a series of lectures in an article called "Explain versus Predict" that gets at this issue. And one of the things that I think about the course, but I'm also coaching, in fact, even my consulting colleagues, sometimes we'll get into, make sure we're listening very carefully to the client or, our manager or thesis committee or what have you, right? As to what they're looking for. Are they looking for an explanation or are they looking for a prediction? Because what a lot of machine learning folks will do that they'll potentially make a serious mistake is, wow, I'm 94% accurate with this thing. Clearly, it not only predicts, but also explains, right? At that level of performance, clearly it understands what's going on, and it also offers an explanation, and that's where you have to be careful. Or the reverse, someone very carefully goes through the steps of the statistics life cycle, and things are statistically significant. They're meeting mathematical assumptions on the whole 9 yards, and they go, oh, this is so solid as a research analysis. I bet it's fantastic at predicting too.
And often not the case, because as we all know, with sufficient data, any non-zero effect size will become statistically significant.
Yeah.
And so, yeah, I mean, if you're doing epidemiological data and you've got millions of cases, you could have a model that predicts, 2% of the outcome, and it would be statistically significant.
A buddy of mine, when I was an SPSS software trainer, was a retired statistician from government, and he would love to write in when these television advertisements, how quaint, right? A television advertisement would make claims about tooth decay or something, and he would write to the companies. He'd write to whatever big company put out this ad, and he would put the articles, and he would just and in one case it was significant to 5 decimal places or something, but the difference between the treated group and the untreated group was 1/10 of a cavity across all of childhood.
Yep. So this gets us back, by the way, to something that something that a lot of people who use SPSS are, for instance, academic researchers. I mean, SPSS stands for Statistical Package for the Social Sciences, originally in any case. Now it stands for nothing.
Yeah.
But developed for people who were trying to get, usually working with small data sets, dozens or at most hundreds of cases, but trying to do a little bit of theory building and understand the causal mechanisms of what was going on, facilitated by randomized controlled trials. And so SPSS has always been a really great tool for that. There are obviously a lot of other tools. I mean, I just want to mention, we have just a couple minutes left. Aside from the fact that you can build on SPSS substantially, Keith mentioned his courses sometimes go over into SPSS Modeler. I know people who've used SPSS Amos, but there's other approaches. Most people in the data science world will use a programming language like Python or R. Because I come from the research side of things and not the computer science, I'm partial to R. That's where I do my work. I have several courses on R in LinkedIn. The nice thing, of course, is that there is integration. It is possible to run R and Python code in SPSS.
Now, I don't get into that in my courses. I've taught that, but I don't get into SPSS programming. And my guess is that you don't either. Do you mention?
I just mentioned that it exists.
Okay.
Because truthfully, in those situations, I'm much more comfortable just going straight over to R and working from there. I will at times use SPSS to prepare the data, especially for, it actually is really good for certain data wrangling tasks, and then bring it over into the other ones if I need to do a different kind of modeling. But I guess we've only got 1 minute left. So I just want to remind you one more time that we do have, the topic that we're talking about, what inspired this is that on LinkedIn Learning, we have a learning path, which is a collection of courses. It's 6 courses on SPSS, 1 by me, 5 by Keith. And this link, bit.ly/SPSS-path, will take you to that. And you can get started on that. And also, you can contact me. You can contact Keith on LinkedIn. We're both very active there. And we can connect with you and see how you're able to use these courses in your own work. Keith.
Art, have you decided what your free course is going to be this Friday?
Well, it's going to be, I have to see what the date is. 1, 2, 3, 4. No, I have not.
Do you want to make it foundations?
I will share.
And then a week from Friday, on the first Friday of April, I'll do the second course in the series. So that way folks could get started.
SPSS Foundations will be, I'll share that for free on Friday under this hashtag, Free Course Friday, on my LinkedIn account.
And the following Friday, I'll do regression.
Under Free First Fridays, do the regression. And we'll get you started on that, folks.
Yep, and you can follow those hashtags now. And within the courses, there's a Q&A feature. That's a great way to identify us as well. And then if you're following one of us and not the other, hopefully you'll take care of that right now.
Left
And
over.
there's bound to be more of these, either individually or even together, in the months ahead.
All right. And with that, folks, I am going to say thank you so much for joining us. I will end the stream now, and the video will be available almost immediately on both LinkedIn and on YouTube, and hope to hear from you in the future. Thanks so much, folks.